In section 7.2, we are going to add and subtract polynomials. Adding and subtracting polynomials is the same as combining like terms or simplifying expressions. So we do know how to do this. We just haven't done it with quite as many variables and exponents. So it says simplify, and then put the answer in standard form where possible. Standard form is when you go highest degree to lowest degree, or highest exponent to lowest exponent. Okay, so I'm going to go ahead and look at A. I see all these terms. For them to be like terms, they have to have the exact same variable and the exact same exponent. Because I want it to go into standard form, I'm going to start with the highest exponent I see. I see I have a 5x to the second. That's the highest exponent is the x to the second. Are there any other x to the seconds? Yes, there is. If I do 5x to the second plus 2x to the second, I have 7x to the seconds. Okay, now that I did the x to the seconds, I'm going to look for the x's and see if I can combine any x's. Here's an x. I have 3x plus x. So 3x plus 1x is positive 4x. Okay, what am I left with? And then I just have this plus 11. Okay, this is my final answer. I combined all the like terms. This is in standard form because it goes from the highest exponent to 1 to no exponent, standard form. Okay, for B, I'm going to do the same thing. And I'm going to, because I'm putting it in standard form, I am going to start with the highest exponent and then work my way down. So the highest exponent I see is the third power. So x to the third. Are there any other x to the thirds? There are not any other x to the thirds. So this is going to go first. Okay, now I'm going to look and see if there's any x to the seconds. I see there's a positive 2x to the second minus 6x to the second. So 2 minus 6 is minus 4x to the seconds. X to the second, let's look for some x's now. I see I have a minus 5x, minus 7x. Minus 5 minus 7 is minus 5 plus 7, 12 x's. And I still have this plus 3 at the end, so I'll put the plus 3 at the end. So I combined all the like terms, and let me just check and make sure this is in standard form. If I check it, highest exponent is 3, 2, 1, no exponent, so it's in standard form. Okay, for example 2, I'm going to distribute, and then I'm going to combine the like terms, which we've done before. This just has more exponents to it. Okay, so because I see a number in front of the parentheses, I am going to distribute. So 5 times x is 5x plus 5 times 1, 5. Okay, I see there's more here, so this is positive 3x. 3 times minus 5 minus 15. Okay, I'm going to put it in standard form. I don't even see any exponents, but I do see some x's, so I'll go ahead and look for x's to combine. 5x plus 3x is 8x. And then I have 5 minus 15. 5 minus 15 is going to be a negative, and then if I subtract, I get 10. Okay, this is my answer. This is in standard form because the x, that's x to the 1, and then the last term has no x at all. Okay, I'm going to keep going. Okay, I see parentheses again, so I'm going to go ahead and distribute. 2x to the second minus 10x plus 3x, 3 times 4 plus 12. Okay, now I'm going to go ahead and look for like terms. I see the x to the second is the highest exponent, and there's no other x to the second, so I'll leave it as 2x to the second. Let me see if there's x's. There's a minus 10x plus 3x. Minus 10 plus 3 is going to be a negative because the negative is bigger, and then when I subtract, I get 7x's. And then the plus 12 at the end comes down. This is standard form because the highest exponent is 2, 1, nothing. Okay, for C, same, just gonna have a negative on it. Okay, 7x to the second minus 35. So 7x to the second minus 35. Okay, when I distribute, keep in mind this is a minus 3, so minus 3x. Okay, minus 3 times minus 4, minus times minus is positive. 3 times 4 is 12. Okay, I'm going to go in order. I see there's the highest exponent is an x to the second. And I see 7x to the second, but I see nothing else. Okay, I'm going to look for the x's next. Are there any x's? There's this minus 3x. So I will put that next. And then what's left? I have negative 35, positive 12. Since the negative is bigger, I will keep the negative, and then when I subtract, I get negative 23. Okay, this is my final answer. It is in standard form because the squared goes first, then the x, and then no x at all. And if I had it out of standard form, I would just rearrange it till I got it to the correct spot. Okay, now we're going to add polynomials and subtract polynomials, but it's exactly what we were doing above. I just make it sound fancier. Okay, so if I look at A, it has 3x squared plus 8. It's in parentheses, but there's not actually any number in front of it. So it stays exactly the same. Okay, I'm going to go ahead and look at the second parentheses. It has 5x minus 1. It's in parentheses. There's nothing out here. Technically, it's like a 1 or a positive 1. But if I do positive 1 times 5, it stays positive 5x minus 1. Okay. So I'm just going to look for like terms. Okay, let's see. I see there's a 3x to the second. Are there any other x to the seconds? No. Okay, let me look and see if there's any x terms. There's this positive 5x. And then I have positive 8 minus 1. 8 minus 1 is positive 7. This is my final answer, and it is in standard form. Okay, B, I'm still adding. So again, I have the first polynomial is in parentheses, but there's nothing in front of it. I can pretend like there's a 1 there, but it wouldn't change anything. Since there's no number to distribute, it really just stays the same since I'm adding. Okay, now I have plus 3x squared minus 8x plus 9. There's no number. So I don't have anything to distribute, so I can keep it the same. Okay, now I'm going to look for my like terms. X squared is the highest term, so I have a negative. This is like a negative 1, positive 3. So 3 minus 1 is 2x squared. Do I have any x's? 5x minus 8x is minus 3x. And then positive 4 plus 9 is plus 4 plus 9 is 13. Okay, and then the last adding polynomial is very similar, but I just added some extra variables. Okay, so there's no number in front of the parentheses, so I'm going to go ahead and leave this as x squared plus 3xy minus 5y squared. For the second parentheses, again, there's no number in front of the parentheses, just a positive, which does not change anything. Okay, now standard form on this is a little weird, so I'm not going to worry about standard form, but I am going to worry about finding my like terms. Okay, so I see this is an x squared. Are there any other x squareds? Yes, right here. So this is 1x squared plus 1x squared, which is 2x squared. Okay, now I have this weird 3xy thing. So for it to have a like term, it also has to have an xy. So 3xy, here's another xy. This is like a 1. So 3xy minus 1xy leaves me with 2xy's. And then I have negative 5y squared, negative 6y squared. So negative 5 minus 6, negative 11. And they stay as y squared. This is technically standard form, but if it has more than one variable, we're not going to worry about standard form. Okay, the last thing is we're going to subtract, but again, when you're subtracting, all I'm going to do is distribute the negative and do the like terms again and put it in standard form again. So it's always going to be distribute like terms, answer. Okay, so let me look at the first parenthesis, y squared plus 4y plus 2. There's nothing in front of the parenthesis, so I'm going to go ahead and just bring it down the same. Okay, now for the next one, there is a negative here, so I'm going to distribute the negative. So now this is negative 2y squared. If I distribute a negative and it's already negative, it makes it a positive 5y. And if I distribute a negative to a negative 3, it makes it a positive 3. So it changed all the signs on the second polynomial. Now that it is distributed, I'm going to look for like terms. The highest exponent is y squared. So 1y squared minus 2y squared. 1 minus 2 is negative 1y squared. Or you could just write negative y squared because we assume there's a 1 there even if it's not written. Okay, let me look for the y terms. I have a positive 4y plus 5y. And I have positive 2 plus 3, so positive 5. So negative 1y squared plus 9y plus 5 is standard form, or I could write negative y squared plus 9y plus 5. Okay, B. Okay, again, the first one has no number in front. So I'm going to keep the first parentheses the same, but the second parentheses have a negative. So I'm going to distribute the negative. So this turns into negative 2x squared. Negative changes the minus 6 to a positive 6. Then like terms. Let's see, 5x squared minus 2x squared is 3x squared. 4x has no like friends. Negative 1 plus 6 is going to be positive. 6 minus 1 is 5. Standard form, final answer. Okay, last two. Okay, let's see. First one, keep it the same because there's no coefficient to distribute to the parentheses. For the second one, because I'm subtracting, I have to distribute the negative. So negative, negative makes this a positive 4p squared. Negative, negative makes this a positive p. And negative 3 makes it negative 3. Okay, then just look for the like terms. See, 1p squared plus 4p squared is 5p squared. 1p plus 1p is 2p. 3 minus 3 is nothing, so I'm going to leave him off. He canceled himself out. Okay, last one, D. Okay, I'm subtracting. So the first one stays the same. The second one, I'm going to distribute the negative, so this is negative 3k squared minus minus 6 makes it positive 6. Okay, the highest exponent would be the k squared. So this is negative 3k squared. Are there any k's? There's this minus k. What's left? Positive 5 plus 6 is positive 11. Done.